Monika Seyfried for you. So big round of applause.
Thanks so much. It's a little emotional because I see many friends and people from 10 years ago when we were studying together, so it's fun. Yeah, but thanks for coming. Thank you to the Institute and to the university for having me. It's a big pleasure. I'll talk a little bit about my practice today and specifically about the project that Pierre mentioned. I wanted to start off with this kind of like provoking, perhaps, question. Is technology the new nature? And I suppose I wanted to ask you that question because it's something that really inspires me. I'm very much inspired by this kind of idea that technology can become nature and nature can become technology. It can feel a bit woo-woo, but that's just something that I find extremely inspiring, especially lately. I feel like just as nature is really surrounding us and sustaining us, technology is sort of like acting in a similar way. You know, there are these like nature forces that are around us, air or water. These are invisible things that are feeding us actually life and information. And I feel like sometimes we don't see the codes and the networks that are running around us. So I don't know, I just sort of see these similarities between nature and technology in some ways, and I just personally draw quite a lot of inspiration from it. And I think the simplest example for that to me is when we try to see how we're trying to understand technology through language using, let's say, nature. When we try to use certain metaphors, when we want to hide things that are, let's say, big and noisy and take up a lot of energy, like server farms, and we call it the cloud, so that it feels light and vapor, and then when we really want to make sure that someone understands that there is something wrong going on within our computer, we call it a virus. And there's more of these amazing examples to me, like seed funding, streaming, having a bug. So just from that little, in that little space already, there's to me quite a lot of interesting similarities. This is a bit of a cliche, perhaps, question, but there is this sense of, in the past, people were looking up at nature and they felt that this is this like kind of mysterious, big, awe-inspiring thing. They didn't know much about it, yet they were, part of it. And I feel like, to me at least, the technology inspires that sense of wonder and can inspire that sense of wonder. And I think that's why I found myself, after interaction design, like some of you are studying, stepping into that space of speculation, of exposing people to that kind of sense of wonder that technology can provide to us as an experience. So I really feel comfortable talking and creating spaces by running exhibitions or experiences where people can step into that faraway future that is kind of driven by a certain technology. That is sort of, this is where I'm trying to explain to you what's my background and how I try to weave in all these subjects together. But yeah, also, as every designer that is trying to work with different technologies, we try to find our own mediums. And for me, for sure, it was photography and film at the beginning. I tried a little bit of coding as well and programming, and I understood the language of machines to a certain extent. But there's been this like other coding system that became very, very interesting to me recently, which is the DNA, something that was uncovered in 1953. And that's where the whole journey started. Because to me, nature is the original coder. DNA is this like, a little coding mechanism that has carried live instructions for billions of years for us, for nature, It's been sensing, it's been coding, it's been changing itself, but it's been this kind of like, to me, almost like a little, computer, like a code. And I found it so fascinating that, you know, these things that you maybe have seen online, you know, human DNA is long enough to go from Earth to Sun and back over 350 times. It's a long computer. And you have plants such as Paris japonica, that's genome is 50 times longer than the human's genome, you know? So it's like just like this little plant that is probably, might be much more, I don't want to say intelligent, but could be fed with much more information than we are, which is maybe an interesting thing to think about. So I really like to think about that. How can we maybe interact with that code in nature? And I've recently also discovered that you know, trees, for example, they are already storing quite a lot of information. We can already learn from their DNA or something that is called eDNA, which is essentially DNA of other insects and other matter and material that you can find on the trees. We can actually trace back quite a lot of information about evolution through researching that. So we can learn about extinctions, migrations, past ecosystems, just by researching DNA. And then maybe this is not directly related to DNA, but, you know, trees record climate history. We can study their tree rings and understand, you know, more about the droughts that were in the past and just like other things they've experienced. And then I guess I found myself in that moment of, you know, it's one thing that we're no longer just read nature's code. We're also beginning, or we are already, we're able to overwrite it with our own, and it's our choice of, you know, how we want to manipulate it and how we want to get in contact with that material in general. And this is where I sort of came across DNA data storage. So probably some of you are familiar with DNA data storage, some not. It's essentially where you can use a digital file and encode it into synthetic DNA. This is the process. It's a bit of an old school graphic, sorry about that. But you essentially take a picture or a music file or, you know, poem, video, whatever. You translate those files and convert it, into binary, and then you encode it. So you create based on that essentially a synthetic DNA. And you can have that DNA, and it represents your file. And if you want, you can read it back as well from the DNA. So all you have to do is sequence it back, and you'll hopefully receive the same picture without any disturbances. In a nutshell, that's sort of how it works. But what's so amazing about that medium is that it's extremely, extremely dense. So this is one of the synthetic DNA I was working with a couple of years ago, and it's just like a little dot that can potentially, you know, store, you know, I have here 215 terabytes of DNA in just 1 gram of, terabytes of data in just 1 gram of DNA. So it's just like theoretically an extremely, extremely dense medium. That's why people are pretty excited about it, you know. There are other things and other qualities that are amazing about DNA data storage. It's you know, it's hard to break. I mean, I think sometimes you think about these like Jurassic Park. Some people in some city in the world found traces of mammoths, you know, and that's coming all from DNA because it's just so, it's like it's hard to break. It's hard to get rid of it. And perhaps it's also energy efficient. I mean, I'm saying perhaps because it's just an early technology in my view, and you need a lot of infrastructure around it to sustain it, but essentially it's just powder or water, so you need a fridge and you can store it for a long time with just electricity, a little bit of electricity. So knowing all of that and being so excited about, you know, like, oh my God, wow, like I can store information in DNA, and then I can, like, what can I do with that DNA? I can like embed it in myself, like I can introduce it to other organisms. I started being really interested, and at the time founded this project Grow Your Own Cloud, where I was really interested in, like, how can we start storing digital information in different organisms. I think at the time also I was really interested in plants. I think that's just a beautiful way to tell a story about this potential future. And how would I was just thinking, what it would mean if we would start storing, one of the greatest pictures that humanity made that are capturing certain history in an orchid or other flower. Just was mind-blowing to me, and led to, trying to think quite a lot about this subject of digital data storage in living matter. And first off, I, with the team at the time, started portraying and building this kind of spaces where you can imagine your memory being stored in a flower. So back in the days with the Grow Your Own Cloud project, we did this pop-up experience in Copenhagen, which was completely speculative. We just invited people to come in and store their pictures and videos into flowers, and people were really, really into that idea, and they didn't even realize that this is a speculation, and that was kind of also mind-blowing to me. It was just a theater that worked a little bit too well, in my opinion, and then here I am 7 years later, like thinking about it still. So years later, I was also, still being at this kind of intersection of science and speculation, building this yet another experience called the Data Garden, where you can, where visitors could enter this like new data storage facility, let's say, and interact with the plants and decode information. And it was kind of, it was fun. It kind of provided a certain vision. It didn't help to progress as much on science as I guess we wanted to, or I wanted to. So years later, after pandemic, and actually recently, I decided to take on one more journey to move from that kind of speculation to the hard work, to the, to the lab bench. Like, by the way, I'm not a scientist. I work with scientists. I have a major in arts and in interaction design. So this is like super new to me. I mean, it's very fascinating, but yet, it's not like something I can figure out with ChatGPT in 5 minutes, unfortunately. So this is the time where everything I'm gonna say is like, really just because of these people. I mean, I think I'm here to just, I'm here to tell you about this project, but honestly, like each one of them is contributing so much into building this thing that it's just been super exciting to have two scientists on board recently, and a researcher, design and artistic researcher, Anneli Berner, to take that little step further and start working a bit more, not in speculation, but in the lab, which is kind of fun. So between 2025 and 2026, actually until early next year, we got a new lab in Brooklyn, in New York, and started progressing on trying to look at this technology from the perspective of working on it in the lab. What is actually possible? I think we made, we sort of jumped onto wanting to figure out quite a lot of things, and I'm excited to tell you about them. The first thing that came to our mind is, like what are the potential applications of storing digital data in all sorts of different organisms, like living organisms in general, like bacteria, plants and other things. Can we think about food security, agriculture? Can we think about environmental sustainability, archiving, culture and history? And essentially what we decided to focus on, I mean, I'm also learning that it's nature, it takes time, you need to be patient with it. You cannot have results tomorrow as you can in Figma. hero plant, Arabidopsis, is a model plant that we're working with. And we're just trying to encode text files onto that plant. Why it's called a model plant is because scientists use it in an everyday to test certain different technologies on Arabidopsis. It just flowers very fast, you know, so you can have new generation every 2 to 3 weeks, as far as I remember. So we're working with that plant, and this is sort of the design that we're executing at the moment. So we have this synthetic DNA. We then create a bunch of different things in the lab to create what's called plasmids, so little DNAs, like those circles of DNAs, that then can be moved into different bacteria that will almost like deliver this DNA that represented information into the plant. And sometimes it's actually, it's a fresh stuff, like we've been just doing that 3 weeks ago. But on the second video, you can see that, you know, there's some spark happening, and there's a lot of quite like, unexpected processes that are, actually working. And then last week, was the moment where we've been all celebrating, because it was the first time we actually introduced the DNA with a short text, act now, wow, into a plant, and that's how it looks. It's called floral dip. It's essentially you bathe a plant flower. It's important in the solution that you've been working hard on in previous steps, so that it absorbs the DNA and hopefully integrate it. So what we're trying to do with that is hopefully this plant is now happy, it's now growing, and it's going to have, the next generation soon, and we can start testing, what happened with that information on the first and second and so on generations. So that's cool. That was a very, very big moment for us. And then onto what are the other things that we're thinking about is trying to choose from these amazing organisms, papyrus, rose, maybe a tree, and green algae, ones that we would also progress when it comes to science. But we want to do it in this kind of like a bit more of a, give it a bit more of like a storytelling angle. So we chose papyrus. It's a hard organism to work with. It's a different process. You need to work on a tissue culture level. Maybe some of you are familiar. But it's also, to me, a very beautiful plant. The plant that was used to record information back in the days for a long time. Iconic plant, really. So I thought that's maybe the plant that could just represent a certain message. So we've partnered with Lingua Eterna, which is this institute that is working on making sure we keep a record of endangered indigenous languages. And we've created that little, I wrote here a library. It's actually more, I don't know how you call it in English, a codex. It's a little bit of information about 10 to 11 different endangered indigenous languages, where we say what's the name, where's the origin, and then this is hard to explain, but bear with me. We are writing how each of these languages, how do they translate or understand the word world, earth, and it's quite interesting because some of them would, translate that as ground soil, some of them as rose, apple, continent, Mother Earth, or just world, and this is super beautiful to me because I'm working with big constraints. We cannot encode like a whole. You might be thinking already, okay, like how much data you can actually encode? Like not a lot. it's actually quite expensive, and the more information you have, the longer the DNA is. Therefore, it's just harder to like work with it physically. So with this project, we were trying to really get into an essence, and I think this essence is kind of delivered. Like you can get a sense about a community by just reading that one word that they use in among them. I hope that makes sense what I'm explaining. Yeah. Okay. Cool. And then my hopes are that we can experiment with music. I'm talking to some artists right now and trying to find like someone great that would allow us to use their 10 seconds of music to encode into rows. And also thinking, this is maybe a little bit more of like a speculative angle, but I told you previously about how trees are already recording quite a lot of information. So this is definitely where we are just brainstorming internally, like how could we transform trees into living communication systems and allow them to speak in real time about their states and environments. I'm keeping it in a very more of like this speculative bucket. It has a lot of pros and cons. This technology, which comes down to questions and ethical reflections, obviously. So there's probably a lot of questions that you might have. What happens if the organism dies? What happens with the data? I mean, I can definitely provide you with some answers, but I will probably have more once we finish the actual lab work. But if the organism dies, the data is sort of still there. I mean, you can still read it back technically. Me myself, I haven't tested it yet. But more important is, like what are the environmental implications of this kind of technology? Like how can we build it in a way that is safe? That do plants even want to have data inside of them? Like why we're doing it? And it's just a big question, I'm just here to say that we are, trying to explore it as far as we can, and it is a concern as much as it is also possibly a very beautiful scenario that can hopefully also provide some spin-offs and just interesting research that we're doing. So. The last thing that I wanted to chat with you about is this environmental kind of research that we're running at the same time when building this technology and trying to build this kind of like little CO2 calculator, or try to understand, like if this would be possible on a larger scale in the future, like how much actually we would contribute to saving CO2 or using less land or using less water and etc. And the numbers I'll show you are in progress, so please don't get too attached to it. This is just like environmental assessment that's being done by Annelie Berner. She's amazing, but of course we're a small team. We're trying our best, but just so you know. So what's interesting is, what happens when you upload a photo to a cloud just once. There's a bunch of different things that you're kind of connecting to, and that just creates a little footprint. There is a 0.3 kilogram of CO2 that you're using in that process. There's quite a lot of, actually, it's 3.5 millimeters of water. That's kind of a lot to me, like for one photo. There's some land use that needs to be used in order to provide you with that service. But what's crazy is that it's not only that you like upload it once to the cloud, like you probably scroll through your phone and you try to find this photo or just appears suddenly. So you're basically constantly like interacting with that photo. So we started just brainstorming, what is the environmental footprint if you request to see that one photo, other photos, 10,000 times a year, which is quite a lot. But then I'm wondering, like, maybe it happens that I'm interacting with my photo album 10 times a year. So then, this footprint is just growing. And that is because it goes on this, what we call in the project, this tangible journey. So from your device to networks to a server, each of those like little journeys where you want to connect with that information, and the maintenance of those railroad tracks require energy, materials, and it's just we're trying to unpack it. There's a lot of kind of different things that are like actors that are kind of then making up these numbers, but it's in the end like quite of a big process. So we started just like, you know, comparing it, like really, okay, for 1 terabyte of data, what's the implication now? What is it if we use DNA data storage? And what is it when we want to do it within the plant? Again, this is just still in progress, but it's where we're heading right now with this research, I suppose. And yeah, thank you so much. I've created a little Instagram to start capturing journey for this moment in New York that's going to run until February. There's one post that you can interact with. There's 0 followers, so who's the first? The first follower will get a plant or a bacteria. No, but if you want to just like hang out with us through that channel, please scan the code, and then you have my website and some other means where we can interact. We're always really happy to have anyone that's interested to support this research in any way. It's such a crazy journey that, yeah, it's just fun to, be around other people with that. Yeah, cool. Thank you so much.